It's the Henning and Harkin show again.
Woo.
Part 2 for drawing
Yes.
Bohr models.
Yes.
We're actually finishing up because the bell rang yesterday.
So we have to finish that last video.
So what we wanted to show you was what happens on that outside energy level.
Yes.
That very last one, which is what we call valence electrons. And they're the most important electrons
yes.
out of all 13 and out of all the electrons on any atom, because as you see down here, they help us understand why we make compounds.
Yes.
Because those are the only electrons that start interacting with the other electrons of another different element on there. So they're really important for us to understand.
Yes.
So what we did is, if you remember, we have 2. We wrote the number 2 and the E for electrons on the energy level on that first one because that's all it could hold.
Yep.
We wrote the number 8 on the second energy level because that's all it can hold.
Yes.
And then we have 3 electrons left. So we're going to use the dots for those 3 rather than writing a 3 and the E on there, and you'll see why in just a second. So this is a completed Bohr model.
Yes, that's how you should draw it.
Of aluminum.
Yes. So
And
draw that in your notebook.
Yep. And we also can use those 3 valence electrons to draw what we call the shortened version of a Bohr model, and it's called a Lewis dot diagram.
Named after a guy, Lewis, who discovered it.
And we use dots.
And we use dots.
Yep.
And it's a really easy way to see which element's going to want to combine with a different element.
Yeah, it's really awesome. Okay, so we're going to go to the next slide. We are going to go to the next slide.
It's going.
There it is.
There we go.
And here's the abbreviated version of a Bohr model. It's really simple.
It's so simple.
You're going to get the symbol for the element.
Look that up on the periodic table.
Because you get to use your periodic table on the test. And then you're going to, I like to say, wrap that symbol in dots.
Yes.
But only the valence electrons.
Yes.
So I didn't put 13 dots around there.
Oh, yeah. You just did the dots that we drew in the other model.
Right. So we're going to put those 3 dots, and then there is a rule. You can only put 2 dots on one side of the symbol. So you notice I have 2 dots above, and then I have 2 dots to the right. You could put 1 dot, 1 dot, 1 dot on each. So you have to think of this like I tell my kids, where's my little mouse here? I say make an imaginary box that this symbol is in. So top side of the box, bottom side, left and right on there. Or left and right, depending upon what your left is here. So you could put 1 dot on each side, and it doesn't matter. You just need 3 dots on there. That's it.
Oh, and you can only have 8 total around the hole. There's only spots for 8 electrons. So,
and that's because the outside energy level, no matter how many there are, no matter if there's 6 or 4, they can only hold 8.
Yes.
Yeah. And scientists have no idea. They don't know why. They just know that's the way it works.
Yes, 8 is great.
8 is great. Oh, I like that. Yeah. Now we're going to actually practice some on the whiteboard. So we're going to stop part 2 and we're going to go on to part 3.